Okay, ladies and gentlemen, I want to begin with problem number 1, summarizing univariate data. What I had suggested in the homework hints was that we need to draw our two distributions on the same axis. Okay, remembering skewness is fewness. So our distribution 1, we are told, is skewed right, which means it's going to have a long right tail. So this is distribution 1. It's got the long right tail, and we know because it's skewed right, the mean is going to be pulled in the direction of the skewness, so the mean will be pulled in that direction. So the mean will be somewhere in this direction, while the median stays closer to the peak. And then we have distribution 2, which is skewed left, which means it's going to have a long left tail. Okay, something like this. This is distribution 2. It has a mean that's going to be pulled in the direction of its tail, so its mean will be here relative to its median. And there was one other criteria that it gave me. It said that the mean of D1 is lower than the mean of D2, and that is how I've drawn it in. If I had that not drawn correctly, I would have just adjusted where I had put the mean. But I want to give myself a picture to start so that I can make sure I've fulfilled all of the requirements. Now all I need to do is go through a checklist and look at the statements. I literally have the location of each mean and median. I can even specify even further. This is median D1, mean D1, mean D2, and median D2. So statement 1, also, they're asking us which is not true. That not is not bolded, it's not italicized, it's not in all capitals. It's easy to sneak in. Hopefully, though, if you missed an important word like that, you would catch it when you start to see that, wait, statement A is true, statement B is true. You never want to just find an answer and circle it. If you do, oftentimes you'll miss key problems that are a not, or which one doesn't work. Okay. So A, the median of D1 is lower than the median of D2. That is definitely true. The mean of D1 is lower than the median of D2. That one is also correct. The mean of D2 is lower than the median of D1. That one appears to not be true. Hopefully we don't find any others that don't work. The median of D1 is lower than the mean of D2. That one is true. And the mean of D2 is lower than the median of D2. That is also true. So C is and was the correct answer. Again, very easy problem if you draw your distributions and label them correctly. If you're not dealing with a very clear picture, this problem can be easily confusing. The mean of the weights of a group of 100 men and 100 women is 160 pounds. If the number of men in the group is 60 and the mean weight of the men is 180 pounds, what is the mean weight of the women? This is a weighted average. Weighted average is two things. It's the percent of the distribution that is made up by a particular trait and what the mean of that trait is, added up with all the different traits. In this particular case, we only have two traits. We have men and we have women. In order to figure out a weighted average, you need to know what percent each is. So we have 60 men. 60 out of 100 is 60%. They don't tell us what percent our women are, but because we only have two traits, women must make up the rest of our sample. Therefore, it must be the 40 out of 100, which is 40%. We also know that the mean weight of the men is 180 pounds. We do not know the mean weight of the women. That is an unknown. In this particular case, we are able to find that because they give us what the weighted average is. So the weighted average will equal the 160. So the proportion of the sample times that mean, all those pieces added together, give us our weighted average. In this case, we know the weighted average. We're asked to find that missing women's weight. What was the average weight of the women? And so we solve this with simple algebra. 0.6 times 180 is 108. I subtract 108 from both sides. 0.4x equals 52. Divide both sides by 0.4. And x equals 130. The correct answer was C. The problems on here are out of order, so I'm going to the box plot, which was the first question on the back. Okay. It takes different time for workers to perform the same specific task, as it is shown in the distribution below, which of the following statements must be true. So what we need to do here is look at each statement and determine whether or not it appears to be true. Before I do that, I'm going to take a look and see that this distribution certainly does not seem to be symmetric, okay? Although it's not a severe skewness, it's definitely not symmetric, which means that there is some skewness. So which side is longer? I go from a little bit below 55 to over 65. That's more than 10. And here I go from close to 70 to 80. So the left side is definitely longer than the right side. If the left side is longer than the right, that means I have skewness in the left direction. And if it's skewed left, then I know that my mean will be less than my median. These are all the things that I want to pick out before I even begin to look at the statements, because these are the type of statements that they're dealing with, and it's helpful for me to have an idea of what I think is going on before I let them influence me with their statements. So A, the 25th percentile, that means they're talking about Q1. So the 25th percentile Q1 is greater than 70 minutes. Here is Q1. Q1 is clearly not above 70, so statement A is incorrect. Statement B, the distribution is skewed to the left. I'm going to put a mark there. I think that that's correct, but I want to see if there's a better statement. The interquartile range is higher than 20 minutes. The interquartile range is from Q3 minus Q1. Q3 is approximately 73. Q1 is approximately 60. That is a length of 13. It's not even close to 20, so I can definitely rule out C. The distribution, the median is less than the mean. I've indicated that I believe it to be skewed left, in which case the mean is less than the median. It's definitely not skewed right, so I'm going to go ahead and eliminate that statement. And the distribution median is equal to the mean. That would be true if it was a symmetric distribution. This clearly isn't symmetric. There's definitely slight skewness, and that skewness was direction to the left, so B is the correct answer. Notice I'm taking the time to evaluate each and every statement. I am not simply finding the one that I think is right and moving on. Why is it skewed left? It's skewed left because the left side is longer than the right side. A track athlete specializing in the long jump has a median jump of 6.0 meters with an interquartile range of 1.0 meters. What are the median and interquartile range of the athlete's jump in yards, given that there are 1.1 yards? So they're asking me to multiply by a factor of 1.1. Because they're asking me to do a linear transformation, I know that I want to identify which characteristics change when we multiply. Will my mean change when I multiply? Yes. My measures of center or location do change. How about my measures of spread? Do they change? When I'm multiplying, they do. When I multiply, my measures of spread change as well. So both the median, which is a measure of center, or measure of central tendency, or a measure of location, will change, And my interquartile range is also, that's a measure of spread. So both of these will be impacted by multiplying by 1.1. So I will take my 6.0, multiply by 1.1, and I get 6.6. I will take my interquartile range of 1.0, multiply by 1.1, and I will get a interquartile range of 1.1. So that led to letter B as the correct answer. Which of the following statements are true? Categorical variables are the same as qualitative variables. That is a true statement. Okay, categorical and qualitative are the same. Qualitative, not quantitative. Be very careful. Qualitative. Number 2, categorical variables are the same as quantitative variables. That statement is false. Categorical means that we're measuring a characteristic that can't be described numerically. Quantitative means that we're describing a quantity that it is a characteristic that is described numerically. Quantitative variables can be continuous variables. That's also true. We have continuous and we have discrete quantitative variables. So we have variables are our general term. We have categorical. Another name for categorical is qualitative. We have quantitative as well. Quantitative variables break down to discrete, which generally means we're counting by whole numbers. In a broader picture, it means that there's some finite ending and beginning to the interval of counting. Okay, it doesn't always have to be just whole numbers, but typically that's the type of discrete variable we look at. Continuous variables mean that there is no interval at which you have to stop measuring. It's a continuous variable. Okay, so because statements 1 and 3 were true and statement 2 was false, letter E was the correct answer. Okay, a sample, and that's important that they told us a sample because it will tell us whether we're going to divide by n or divide by n minus 1, consists of 4 observations. What is the standard deviation? There is no excuse for getting this problem wrong. This should have been done on your calculator. In L1, I put 1, 3, 5, and 7. When I do stat, calc, one variable statistics, I look for my S sub x, and my S sub x was 2.58. Those of you that got it wrong, nobody got it wrong that had no work. So I'm assuming if you had no work and you got it correct, you used your calculator. Those people who did it by hand, a lot of people forgot to take the square root. If you do it by hand, which doesn't make any sense, remember that the final step is to take the square root of your answer. And last but not least, which of the following statements are true? The standard error is computed solely from sample attributes. That is not correct. I'm sorry, that is correct. The standard error is based on sample. The standard error is a sampling standard deviation measure. So this statement is true. The standard deviation is computed solely from sample attributes. That is false. You need at least one population parameter in order to calculate your standard deviation. So statement 2 is false. And the standard error is a measure of central tendency. That is false. All of your standard errors, your ranges, your standard deviations, those are all measures of spread. They measure how far away the typical data point is from the center. So that is not a measure of central tendency. It's a measure of spread. So only statement 1 was true, which is letter A. That concludes the answers for homework number 1.